ठीक है, thank
Okay, so we're off and running here. So speaking of that skill review assignment, let me go to it. Where's it at? Oops, in a different class. Of course, this one right here. All right, so skill review, exponents and factoring. Let me go ahead and just download that and we'll work it out here. Just I want to make sure you have that. So, excuse me. So what are we doing here? So trying to skill review and get you prepared for uh, the week's material, the test coming up. So this one right here, there's a couple different ways you could go about doing it. What I recommend doing is to work inside, simplify first. So if we were to simplify first, kind of hone in on this, uh, let's take a look at the 8 and the 6. So you review the 8 and the 6, simplify 8 and 6, I mean. So simplify the 8 over 6, I mean. And so you would do that, and you would get the fraction 3 over 4. Nope, 4 over 3. 4 over 3. Then you look at the x's, and what you do is, or one thing you can do, is to apply the quotient rule, the quotient rule. And if you do that, the x goes in the top, and then you do 3 minus 5 minus 5. But that 3 minus 5 ends up becoming what? 3 minus 5 is negative 2. There we go, take it off. Negative 2. And then the y's themselves, y to the 7th over y to the 7th, those will cancel. Those will cancel. The y part at least will cancel. And so then that leaves it with just the x's. And then everything, don't forget about the exponent of 2 out there. And so we do that. Okay. So how are we going to clean it up? What's the next step here? Notice the y's are gone. The next step here is we don't like to have negative exponents. So we got to deal with the negative exponent. And what that means in this particular case is we're going to take the x part of it and shoot it down across to the other side of the fraction bar. So it ends up becoming the x goes away from the top and ends up going down to the bottom as x squared. By moving it across the fraction bar, the exponent becomes positive. So now this is what we're 4 over 3x squared, and so we give everything its own exponent of 2, so it becomes 4 squared, 3 squared, and then x squared squared. And so that gives us the final answer, 16 over 9. And then x squared squared, remember we apply the power rule to multiply those two exponents. And so that gives us 9x to the 4th. And that's the answer right there. 16 over 9x to the 4th. So you had to do a lot. Quotient rule, negative exponent rule, power rule, simplify a fraction. It's got it all. This is exactly the sort of a problem you would anticipate seeing on the upcoming test. Okay, so next one here, find the GCF between these two. And so remember what you do with this process. You find the GCF of the numbers and then look at the variables. So for the numbers, 18 and 20, that's what I'm referencing, the numbers in front. What's the GCF? What's the largest value that goes into both 18 and 20? And what did y'all say? What's the largest value? So you can go through your list, 1, 2, 3, 6, things of that nature. But what you're going to find is that the largest value that goes into both is just the value of 2. Nothing higher than that. Um, that's it, nothing higher. So for the variable parts then, you look at what they have in common, and what they have in common is just an x and a y. While the z here is not common. We just use the x and the y. Now you look at the x and y and you get the lowest exponent of each. So look at the exponents of the x's. It's 5 and 4. So the lowest exponent over the x's is the 4. And then similarly for the y's, the lowest exponent for the y's is the 3. So that's the GCF for that. The third question here says, okay, now that you know the GCF, factor out the GCF. And so remember what that process is. Once we find the GCF, You put it on the outside of a set of empty parentheses. Oops, I don't know what I'm doing there. Sorry, got a typo. So we put 2x to the fourth y to the third on the outside of a set of empty parentheses. And then you take those terms and you divide it by. But we've sort of talked about this process of pulling out. And so let's do that here. So when I pull a 2 from the 18, well, that's just dividing the 18 by the 2, leaving me a 9. Here, I'm going to pull, remember what I'm pulling. I'm pulling 4 x's and 3 y's. That's what this says, 4 x's and 3 y's. So when I pull 4 x's and 3 y's out of here, how many does that leave behind? So if I pull 4 x's, that leaves me, out of 5 x's, that leaves me 1 x. And I'm pulling all 3 of the y's, so there is no more y's left. And the same sort of process here. The 20 divided by 2 gives me a 10. And out of the variables, I'm going to pull 4 x's and 3 y's. So that means I'm going to pull all the x's. I'm going to pull 3 y's, leaving me with 3 left. And then I have a z hanging back. A z hanging back. So we'll just have to kind of do that as a z. So the answer here is 2x to the fourth, y to the third, parentheses, 9x minus 10y to the third, z. Z. Questions on these two? On how to find the GCF or factor it out? Okay. And so the next one here, multiplying, number 4, multiplying the binomial. So this one you could do the FOIL method. You know, it's 3x plus 5. And that exponent of 2 right there means another copy of that. So you could do this as 3x plus 5 times 3x plus 5, and then just do the FOIL method, okay? Or we talked about one of the special factors, the special multiplication. Remember, we have the special multiplication of a plus b squared, the format at least, gives us a squared, hold on, oops, a squared plus 2ab plus b squared. Either way, either one will work on this, okay? So if we were to, let's go back up here, let's do FOIL. What do we get? 9x squared plus what? 15x plus another 15x, and now we're in the inner. And then plus 25. So giving us, I'll type this now. My handwriting is getting pretty terrible. 9x squared plus 30x plus 25. Or we could do this, you know, oops. Or we could do this, you know, 3x squared, 3x to the second power plus 2 times 3x times 5, that's terrible, and then plus 5 squared. And it gives you the exact same thing, 9x squared plus 30x plus 25. So your choice as to how you want to do it. On the test, it's not going to tell you which way to do it. It'll just say, give me the answer. And so all you have to do is just give the answer, not how you got the answer. So you can be flexible, however way you're sort of seeing it. Any questions on number 4, on how to do that multiplication? Okay, and then the last one here says multiply these. You can do FOIL if you want, but and if you do FOIL, you'll get the right answer. But do you see the special factor, the special setup? What's the special setup? This one will be done by way of the difference of two squares method. So remember what that says. It says f minus L times f plus L becomes f squared minus L squared. And it works both ways on the factoring. So in this case, oops. So it's supposed to be f squared minus L squared. So if we do that here, this becomes 4y squared minus 7 squared. So that gives us 16y to the second power minus 49. If you did FOIL, you would have gotten the exact same thing. Exact same thing.
Would it be 49 squared?
Just, well, it was the 7 that was squared. And 7 squared becomes the 49.
Okay.
By getting 49, we took care of the squared, is what I'm saying.
Okay.
But you can do FOIL if that's your preferred route. No problems with that. Nope. Sorry, went too soon. Okay, so that's pretty good sort of exercise of what you questions you'd be called upon, and I anticipate very similar things. The only thing I don't have this on the skill review, but maybe we'll look at tomorrow, is factoring. Looking at the factoring of the grouping method, factoring of trinomials, factoring of the difference of two squares method, and then also the other stuff that we have to do down here, which is the where is it? Oh, was it this? This is where I said that we're stopping, right? I'll go back and look. So simplifying radicals in complex numbers. So we'll do a review of that tomorrow. Is this it? I'll go back and look. I think it was this was the line that I put where we were stopping. Oh yeah, because it's the 20th. That was, yeah, 2 weeks ago. Okay, yeah, that's it. So I'll do a review. So we'll do some factoring on this, but this is the factoring you're going to have to be prepared. So simplifying radicals and whatnot. Let's do a couple right now. I mean, no reason not to do it. So stop this. Let me go here. Okay, there it is. Okay. So let me give you one to do right here. Suppose I have the square root of 36. What would you say this becomes? Any takers?
6.
Feel free to type it on your calculator too. If you're unsure, you have a calculator handy. What would you say?
6.
6. Oh, maybe my volume is low. It is low. Maybe I couldn't hear you. Yeah, 6. 6. Check it on your calculator too. It's fine. But there are some that you want to be familiar with. The perfect squares. 4, 9, 16, 25, 36. Remember how those are formed? Perfect squares are numbers that have factors that repeat. 2 times 2 gives you 4. 3 times 3 gives you 9. 4 times 4 gives you 16. That's how we build the perfect squares. So be prepared with that, because then I'm going to throw you something like this, something that's not a perfect square. So how do we simplify this such that we don't want to use it? We don't want decimals. Maybe there may be a time where I want decimals, but not on this test. On this test, I want perfect answers. So how would I go about doing something like square root of 24? What would you all say? Any takers? Remember, the process is If it doesn't have a perfect square factor, we look to see if there is a perfect square factor, and there is in this one. We would say this becomes 4 times 6. You give them each their own square root, and then you simplify the perfect square, the square root of 4, and just bring down the square root of 6. So this answer here would be 2 square root of 6. Questions on that? So then let me give you another one. And this would probably be more representative of what I would do. Suppose I had something like this. 7 square root of, excuse me, 7 square root of 18. How would we simplify that one? Okay, let me take it from here. We got to remember that between the 7 and the radical is an 18, is a multiplication. The 18, we're looking for perfect square factors, and so that's 9 and then times 2. Give the 9 and the 2 their own square root, and then simplify the square root of 9 down to a 3 and bring down the square root. So that should be times right there. And then the 7 and 3 on the outside of the square root, because they're on the outside, they can interact, and you can go ahead and multiply them. So it gives us 21 square root of 2. So this may be more representative of the type of problem you'll see when it comes to simplifying radicals. Okay, so then let's take a look at complex numbers. Suppose I have something like this, I to the 26th power. How am I going to do I to the 26th power? Remember how we did that? Excuse me. Remember we did the clock. We did the clock. So I have my clock, and I have the 4 points on the clock. It starts up at the top with what? 1, I, minus 1, and then minus I. Oops, minus I. So how do we know where we are on the clock? So scratch a sheet of paper, you take the 26 and divide it by 4. And that gives you what? Oops. It gives us 4, nope, 6, remainder 2. So that means we go around the clock 6 times, 3, 4, 5, 6. But the remainder 2 is the important thing, because that means once we go 6 times around, we go 2 more steps.
Could you just do 26 times around it?
It's not 26 times, it's 26 steps.
I meant, yeah, could you go to I, 1, -1, negative I, 1, 26 times and then land up? Because I just did, I'm just curious, because I did it and I landed up at -1.
Yeah, it's 26 steps,
Okay.
which is 4 times, 6 times around. So yeah, you could, and
Gotcha.
that's what this represents. It's 26 steps. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, I'm getting
My
lost.
bad.
You can see me, I'm getting lost already.
Yeah.
But the clock is the sort of the reminder here. But you got the right process. You could do that, yes. But the thing is here, it's the remainder that tells you where on the clock you're going to end up. And
Of
so
course,
here
gotcha.
we took 2 steps, and so that's the answer. So that's one way we do these. What's another problem we encounter with these? Let me give you something like this. Oops. 2 plus 3i times 4 minus 5i. Suppose that's something like that. How would we do this? What's it telling you? What's the inclination?
Foil?
Well, exactly right. So first outer, inner, last. Yes. Good, good, good. So let's do some FOIL. FOIL. And when we do FOIL, first is 2 times 4, which is 8. So 2 times 4. And then next is outer, which is 2 times negative 5i, which is negative 10i. And then inner, which is 3i times 4, which is plus 12i. And then last, which is, what color am I going to use? I'll use red, fine. 3i times negative 5i, which is negative 15i. I squared, sorry, I must have made a mistake there. So now we're going to combine like terms. So my like terms in the middle, minus 10i plus 12i gives me a positive 2i. Oops. So bring down the 8. Combine the like terms to get 2i. And then minus 15i squared. But we don't like exponents over the i's. So you got to simplify that. What does I squared become? Well, you got to go to your clock. What's the second step? Oops, what's the second step? In the second step, 1 step, 2 step, it's this one right here. It's the negative 1. So we're going to replace I squared with the value of negative 1. Well, let me write that back actually. So that's I squared. So we say 8 plus 2i minus 15. Replace the I squared with negative 1 now. And so that becomes negative 15 times negative 1 becomes what? Positive 15. So that's 8 plus 2i plus 15. And now we combine like terms again. Which like terms this time? 8 and positive 15 gives us 23, and then just bring over the 2i. So what did we do there? We treated the I like a variable, like for FOIL, and combining like terms. The only thing we had extra was we had to remember our clock. We don't like exponents over the I, so you have to simplify. You have to find the position on the clock that it corresponds to. That's the only difference. So this would probably be more like more like something I would ask you on the test. Because it combines, see now that our questions combine a whole bunch of stuff from prior weeks that I get to ask you about. Let me see, is there really anything else? We'll do factoring tomorrow, but as far as simplifying radicals and the complex numbers, those are the things I wanted to make sure we hit. So we'll talk about some, we'll do some, we've actually been doing, well, actually we're going to do it tonight. So that's the great thing. Let's I guess go ahead and start taking a look at our material here. Because we're going to start taking a look at, we're going to be reviewing again factoring. Because what are we doing? Where do we end up? Oh yeah, here it is. We're taking a look at rational expressions, and basically we're dealing with fractions. But what we're doing is we're taking our stuff with fractions, all the rules with fractions, how to simplify, add, subtract, multiply, divide fractions, and then how do we incorporate this notion of polynomials, which means we have to incorporate our notion of factoring. So we're taking these expressions right here is fraction rules combined with factoring, all in one. Goodness gracious. Okay. Okay, so let's take a look at some of this stuff. And some of what we did the other day, so we don't have to spend a great deal of time. but we'll re-review it because it is helpful, I think, to see some of this. $113. Okay, so one thing to take note of, and what this question asks about, is notice what we have here is we have variable. When we say rational expression, we're talking about a variable in an expression. But what we have also is it is now possible to have a variable in the denominator. And that's okay, except there's only one thing we cannot have in the denominator of a fraction. And what is it? Does anybody know or remember if you've done this? The only thing you can't have in a denominator is the value of 0. Zeros in denominators don't make sense. Try to do it on your calculator. Suppose you had the fraction -2/0. Do it on your calculator, and you're going to get, your calculator is going to tell you, I can't do this. It gives you an error. So that's what this question is asking here is hey, what value is going to make this thing become 0? So that's what you have to do. You want to find the value that makes it become 0. And that value is going to become, or be, 9. The value of 9 makes the denominator 0. So we say x can be any value except that number 9. And so we restrict it. And that's why we say x cannot equal 9. Is we're throwing it out. We're throwing it out, saying that's the one value that makes my denominator 0. I don't like that. Get rid of it. Get rid of it. So the way that you do that then is you take your denominator, set it equal to 0, and solve to find that value for x. And then you throw it out. So let's see more. So here, this one says evaluate the rational expression for the given value of x. So they say the word evaluate, and they give you a value for x. So when you see the word evaluate, what's the process you're going to apply? Do you all remember from the last test? When you see the word evaluate, what's the process?
Multiply.
More generally speaking, when you see the word evaluate, you apply the order of operations. Okay? Just to keep that in mind, you apply the order of operations. So we take our value of 4 here, take our value of 4 and pipe it into wherever you see an x. That's telling you this x is equal to 4. So we plug in all the places. So we'll say 4 minus 2, and then we do 7 times 4 plus 8. And then you just apply your order of operations to simplify the expression. So this becomes 2 over 28 plus 8. And so it's 2 over 36. And that becomes 1 over 18.
12.
1 over 18.
1 over 18.
So just keep in mind the directions to the problems also help you to understand or to identify the process. When you see evaluate, it means order of operations. When you see simplify, it could mean order of operations, but most of the time means combine like terms, apply distributive property, or potentially maybe also the FOIL method. Factor means factor, and you have to use your different processes. So just keep the directions in mind, help to guide you as to what you need to do process-wise. Just always have that. I'm going to keep singing the song because I just want to keep reminding you of it. Okay, so when it says find the restricted value, that's saying what's the value that x cannot be? It could be multiple values, like this one here. We've got to take this expression here, 8x squared minus 3x. 8x squared minus 3x. We want to know the values that make it 0. So set it equal to 0 and solve. How are we going to solve this one? Well, if you take notice, it's got an exponent of 2. When you see that, you want to go back to your processes for quadratic equations. I can use the factoring method. I can use the quadratic formula, whichever way, kind of is handy at the moment. For me, I'm going to factor this. I'm going to take out a GCF of x, and so I get 8x minus 3. Now I set each factor equal to 0. If I'm going back to the factoring method, remember I factor, set each factor equal to 0, and then solve each factor. So this one here becomes x equals 3 over 8. So the restricted values are 0 and 3/8. Those are the values that will make the denominator become 0. So you have to be familiar with your process for factoring, excuse me, for factoring or solving quadratic equations by way of the factoring method or even the quadratic formula. But that's what they're asking for when they say restricted values. They're asking, what are the values that x cannot be? Or another way of saying it, what values of x will make the denominator become 0? So let me pause. Questions on this one? Okay. So let's see. Okay, reduce. When this says reduce, think of it kind of like a fraction. How do we, let's go back to fractions. Let's go back to fractions. If I have the fraction, say 12 over 18, okay? How do we reduce a fraction? Just when we were all the way back in the first week of the class, how do we reduce a fraction? You look
Find the
for a
least
factor.
common multiple.
Say it again.
Find the least common multiple.
Yes. So what's the least common multiple in this case? Not multiple, but greatest common factor, actually.
Yes. 3. I'm sorry. Yeah. Wait.
3.
3.
Right.
Yeah. 3.
So technically the way we're going about doing it is we're going to say, okay, 12 factors into 4 times 3 and 18 factors, and 18 factors into what? 6 times 3. Maybe there's a higher factor. Is there a higher number? Yeah, there is a higher number. What's a higher number that
6.
goes? Yeah, 6.
9.
Not 9. Well, you're looking for one that goes into both. So,
Oh, 6.
yeah, 2 times 6 and then 3 times 6. So notice what we did is we found the common factor, and what are we going to do? We cancel that common factor, leaving us the 2/3. That was the process all the way back then. Well, guess what? It's the exact same process now. The exact same process. So let's take something like this. And essentially what we did is you factor the top, you factor the bottom, cancel the common factors. That's what the process is. Factor. So if we factor the top, 8y minus 24, well, the GCF is 8. Pull out an 8, and you get y minus 3. Now the bottom is 3 minus y. Doesn't it look almost identical to this? What's the only difference?
It's 3 minus y instead of y minus 3. They flip-flop.
Yeah, it just changed order. So the way that when you're in subtraction, the way that you change the order is you pull out a -1. Pull out a -1. So if we were to pull a -1 out, you can do it out of the top one to the bottom one. It doesn't matter. Well, let's do it out of the bottom one, just because that's what I did. It reverses the order. By pulling out a -1, you reverse the order. And so now we have a y minus 3. You cancel the y minus 3 in total, leaving yourself the 8 over -1. And 8 over -1 becomes what?
Eight.
Yeah, -8. 8 over -1 is the same thing as saying 8 divided by -1. 8 divided by -1. But the takeaway here is what? What's the process? Factor the top, factor the bottom, cancel your common factors. Factor the top, factor the bottom, Cancel your common factors. Just like we did over here. Factor the top and bottom and cancel your common factors. It's the same exact process, except now factoring is a little bit more of a big deal. It's a little more of a challenge sometimes. Okay, so here's a perfect one as well. So if we the top here can't factor. The top can't factor. So we look at the bottom. Can the bottom factor? So this is factoring by a trinomial with a leading coefficient of 1. So remember what the process is for that. We look for the values of you can use, like Addie did last week, you can use the AC method on this. It works just fine. And so that's essentially what we're doing. What are the factors of -8 that will add to give you +2? What are the factors of -8 that will add to give you +2? And those factors are +4 and -2. Once you have it factored, you ask yourself, can I cancel anything? Let me throw it to you all. Can I cancel anything? Is there anything that's common to both top and bottom? Excuse me. What would you say? Yes or no? Yes. Anything look the same? Yeah, Addie, you're right. It's not a trick question. It feels like it sometimes when I ask you, but granted. But no, there's nothing common. Even though there's X's up there, remember my comment the other day, and this is the point of what I'm trying to make here, is you can't just cancel X's. You can't take them apart. The parentheses mean they're married. They're grouped together. And for anybody who's been married, really more anybody who's been divorced knows it better. You can't just walk away. There's a whole process that gets in, it's just not easy to do. That's what that does. The grouping symbol is the marriage symbol in mathematics. Where one of them goes, the other one's got to go with it. You can't take them apart. They're a unit. So even though, my point is even though there's an X here and there's an X here, and there's an X right here, you just can't cancel them. The only way you can cancel, excuse me, the only way you can cancel this X is if you have a +3 to go with it. They're a pair, they're a unit. So there's nothing to cancel. There's nothing to cancel. So that's it. Now this one I actually didn't read the problem, but what is the problem asking? It's asking for the restricted values. So when it says what are the restricted values, what is it asking? What are the values of X that make the bottom 0? So what are the values of X that make the bottom 0? What would you say?
-4 and +2.
Correct. Those are the restricted values. Those are what it can't be. So good. So notice they even throw in some stuff from prior units. This is something like you're going to be doing on your test. 9x to the 5th y squared over 12x squared y to the 3rd. That's exactly a test question right there. That's a perfect test question. Maybe. I'd probably throw in one more thing, but I'm going to skip that one because we just did it a few minutes ago and kind of want to maximize your time. But this is what this one's saying. This is a good one. Reduce the following rational expression. So this is where you factor the top, factor the bottom. So I'm going to factor the top. So there's a GCF out of, well, this is, okay. This is not a quick factor. So when I factor the top, I'm going to factor a GCF of x out, and I get x squared minus 3xy plus 2y squared. All of that over the bottom, I'm going to factor an x out, and that's going to leave me with x minus 1. No, x minus y. Okay, be mindful, this thing here, ask yourself, can it factor further? And the answer is yes, it can factor further. So if it can, let's go ahead and factor it. So we're going to factor that trinomial a little further. So I'm going to bring everything else down. And in the numerator now, I'm going to factor it to x. So it's a trinomial. We look for the factors of the 2. They give us the middle value of -3. So that's going to be x minus 2y times x minus y. Okay. So now the top is completely factored. I pulled out a GCF, then I factored the trinomial. And in the denominator, just factor the GCF out. So I'm going to take this x here, and I'm going to cancel it with the x down there. Okay, those I can cancel. Okay, so I'm going to strike those. This x minus y here is going to strike with this x minus y right there. And look at that. This is the only thing that's left behind. So the answer is x minus 2y in this case. That's the answer. Everything else canceled, coincidentally. So when you're dealing with rational expressions, the two big questions are, what are the restricted values? Meaning, what values will make the denominator 0? And then the other big question is simplify. Factor the top, factor the bottom, and cancel any common factors. All right, questions on that? So this is a good homework assignment to do. If you haven't done 4.R.5 yet, I would encourage you to do it because it's a good practice for factoring in preparation for your test on Wednesday. So I'm going to kind of exit this part. So now let's look at the multiplication division. Well, funny enough, the division 4.R.6 and 4.R.7 are actually very similar. The processes are going to be almost the same. It's just they look a little different, but they'll be near the same. So before we get started on any of this, I want to do a quick review. How do you multiply fractions and how do you divide fractions? Okay, so we're not going to do this problem yet. We're going to do this problem. 3/4 times 2 6. How do I multiply fractions? You tell me.
Simplify them first.
Okay.
3/4 is going to stay the same times 1/3.
Okay. Now what?
So it'll be 3/12, correct?
So how did you get 3/12?
I just like 1 times 3 and 3 times 4.
Multiply straight across. Good. So that gives us 3 times 1 on the top is 3. 4 times 3 on the bottom is 12. And then what?
1/4.
Simplify if you can. Exactly. So we're going to cancel the 3 from top and bottom. So that's exactly right. So guess what? Exact same process. That's all we're doing here. We're taking your old rules of fractions, and let's do this one now. If we do this one, what do we get? Oops, wrong one. So if we were to do this one, we're going to multiply straight across. So what do we get? So 21 times 24. 504. So let me do this. 504. Do you see how I got 504? By the way, we can cancel too. Can we cancel the numbers, by the way? Is it possible? If you don't know that, that's fine. I'm not gonna belabor the point. Okay, but do you see how I got 504? Where did the 504 come from?
Could you multiply
21
21
times 24.
21 times 24. So
So,
what? Uh-huh.
sorry.
So
Those two numbers are not restricted to, or like they're not tied to the variables. So we
well,
can do
remember,
that.
how do we multiply? How do we multiply 21s squared times 24t squared?
Right. So you can
You multiply the
separate
numbers first and then multiply the variables. So when I multiply the variables, what do I get?
s squared t squared. Okay.
Right. S squared, t squared.
Good to know.
Now how about the bottom?
$28
So 4 times 7 is 28.
t to the third x squared.
S squared, t cubed. Right. And look at there. This problem is exactly what you're going to have on your test. And we did it just a few minutes ago, didn't we? So what do we do from here?
Can you reduce it anymore?
And if you can, you should. So I'm going to ask you, can we reduce it?
Let me check my calculator.
Okay, yeah. Good. That's a good way to start.
$18?
18. What about the S's?
Oh.
They can cancel out since they're this
They have the
s
same
squared.
exponent. They have the same exponent, so they cancel. What about the T's?
3, it'll be 3 minus 2, right? So it'll be t, 18t.
Close.
Oh, do you subtract? Oh, shoot.
You do
Would it be
subtract.
-1 and then you have to do 1 over 18?
So it's 18 to the 2 minus 3. Remember, it's top minus bottom.
Right.
So it is 18t to the -1 power. How do we resolve the -1 power?
You put it under 1. You bring it to the bottom.
Bring it to the bottom. Remember, it's still a fraction, 18 over 1. And the t, the negative causes the t to move to the other side. So shoot the t down. And so what do we get? 18 over t.
Oh. Oh.
Just the t moves, not the 18. But look at what we did. You knew everything. I didn't show you anything new. All we did is we did a mashup. Take your rules of fractions, pair it with your rules for exponents. Allison, does that help to answer your question about the t?
It does.
Yeah. It's one of those little, you have time. This will be on the next one, but you'll get more practice with this. Okay, okay, now we're going to do this one. So before we do this one, Three over 4 divided by 2 over 9. How do we divide fractions?
Wouldn't you flip the
The second,
right side so it'll be 3 over 4 divided by 9 over 2?
you change the division to multiplication, wouldn't you?
Right. But the flipping action causes you to change the division to multiplication,
Okay.
but that's exactly right. So essentially we turn division into multiplication, and now we do our multiplication and we get 27 over 8. Okay. Same exact process. Same exact process. So what do I do on this one? First fraction remains the exact same. We've changed the division to multiplication and flip the second fraction. Now we what? Now we multiply. Remember, that's the straight across. So that gives us what? 15 divided by 24. Oops, sorry, 15 times 24. 360. N squared. Oof, that's a terrible N. Looks like an R. Mn squared over 30 mn. Do y'all see how I got this part? 360 mn squared. I multiplied the 15 and the 24 to get 360, and then m times n squared is just mn squared. The bottom is 6 times 5 is 30, and then bring the m in. So now we need to simplify.
Would it be 12n to the second power?
Close.
Or would it be to the third power?
It is 12.
That's the only thing.
What happens to the m's?
You can
They
cancel.
cancel.
M's cancel. Good. What about the n's?
Well, usually you would subtract, but we only have an exponent on
So n
one.
n
So
squared
then,
plus n.
hold, let me, so Jana, you're right. So, but what is the exponent over here?
1.
1.
1. It would be just 12n then.
Minus 1.
Remember your quotient rule.
Oh, negative 1.
2, we subtract the exponents. The quotient rule says subtract the exponents. So then, right, I see what you're saying now. You do subtraction to get into the first power, but then we just drop the 1, and it gives us a plain n. Is that what you were saying, Jana?
N.
Yeah, okay.
Yes.
Well, I thought. Good, good, good. So notice it's just a mashup. You know everything. You got this. Anywho. So take your old rules of fractions, incorporating your new rules with exponents and potentially also multiplication. So let's see if we can find one of those. And there it is. Look at that. Look at that. Okay, so when you have something like this, we could do the multiplication, but don't actually multiply. Do not actually multiply. You want, in this sort of thing, when you have polynomials like this, you want to factor. You want to break things apart. And so don't actually do any multiplication at all. You want to factor. So why don't we go ahead and factor first? Okay, so this part over here, none of it factors. So we don't have to worry about that. But it's the first part, the first fraction that can factor. So this first part up here, 64 minus x squared, how does that factor?
8 minus x times 8 minus x
Close.
plus 8 minus x.
This is the difference of two squares method, exactly. And then the bottom, x squared minus 16x plus 64. Well, that's a trinomial, leading coefficient of 1. So you ask yourself, what factors of 64 will add to give me negative 16? And that's going to be
8 plus negative 8.
x minus 8 times x minus 8. Or x minus 8 squared, whichever one. And then we just bring down the second fraction times 3 over x plus 8. Now, normally, we would go ahead and just, bring everything all together. And we can. So at this point, Just bring it all together. But you don't actually multiply. You just bring it together. What do I mean by that? Well, take the 3 here, and now you're going to just move it in front. Okay? You're just going to bring it all together into one giant expression. So it's going to become 3, 8 minus x, 8 plus x. Oops, sorry. Wrong direction. 8 plus x. I did it again. Sorry. Okay, there's my x right there. Okay, and then the bottom, x minus 8, x minus 8, x plus 8. All you do is you just write them. You do not actually do any multiplication. Okay? We are technically doing multiplication, but what we're not doing is we're not going to FOIL it all out. We want them separate. Why? Because remember, we're trying to see if we can cancel some common factors. We're trying to simplify the fraction. So let me throw it to you. Do we have any common factors?
Yes.
Cancel right
2
now.
of them. You have 2 of them. You have 8 negative 8 minus x, and you have the 8 plus x on the top and the bottom. Well, no, you don't.
Close.
You have no, you don't. You don't have any.
How about let me hone in on the 8 plus x. Let me do this one first. This one here. Do I have an 8 plus x at the bottom?
Yes, technically,
What?
x plus 8.
Yeah, this thing here is actually the same thing as this thing here. But Mr. Halverson, they're not the same order. And I would say, or you would say to me, why are they the same? You tell me. Why are
They're
8
just
plus x?
reciprocated.
Yeah, addition can be, you can change the order of addition. 5 plus 2 is 7. Oh, 2 plus 7, 2 plus 5 is also 7. It doesn't matter the order of addition. You can switch those around and you get the same thing. So 8 plus x is actually the same thing as x plus 8. We can turn those around a-okay, no problem at all. So, right, that is indeed, these are indeed common factors. So this one is gone right here. 8 minus x and x minus 8. Are those the same thing?
Not necessarily.
Close, but they're not the same. What's the problem?
Because you can have any number at the bottom. You can put any number minus 8. It's not going to give you the same thing as the top 8 minus whatever.
Right. So think of just regular subtraction. 2 minus 3 is negative 1, but 3 minus 2 is positive 1. So they differ, and do that with any numbers, by the way. You'll notice it's the same thing, but different sign. So essentially what we need to do, we need to reverse the order. Excuse me. How do we reverse the order?
The negative 1 on the outside?
Right. We're going to switch the order here to x minus 8. And when we do that, we're ripping out a negative 1 when we do that. We're going to factor out a negative 1. That pulling of the negative 1 causes it to switch. That's the action. And so now we have that. We only cancel one of them, though. You only cancel the same number you have. So we have one x minus 8 in the top. We cancel one of the x minus 8 at the bottom. And what we're left with is this. That's what we're left with. So what do we have? It's kind of a mess now. I apologize. Over here. Negative 1 times 3 is negative 3 over x minus 8. And that's it.
I'm so sorry. I missed. How did we just like cancel that negative, turn it into a negative? X minus 8.
Mm-hmm.
I was writing my notes down, and then when I looked up, it changed again.
Yeah, well, so 8 minus x, if you factor out a negative 1,
Okay.
it becomes negative 8 plus x. If you were to actually do it step by step, okay? negative 8 plus x. And when you pull that negative 1 out, well, we can rewrite that then. Negative 8 plus x, you can switch that order of addition around to 8 minus x.
Okay.
So factoring out a negative 1 causes the terms to change order. It causes the subtraction to change order. That's how we got this to look like this.
Okay. And I can make a picture of that real quick. Just
Mhm.
have it.
On a test, I probably wouldn't do this to you. I don't like those questions, but you got to be prepared for it on the homework.
Okay.
Okay, and so really now at this point, it's just more of the same. It's just more of the same. This is probably one of the more challenging ones in my opinion. But look at this. We got two fractions being divided. So you tell me, what's my very first step here?
Flip your second fraction
I have
and
division of
change the
fractions, so I got to
multiplication.
flip that second one that is perfect. So it becomes 3x squared minus 48 over x to the 7th times, flip the second one, becomes x to the 5th over x minus 4. Now, at this point, once you have multiplication, don't actually multiply. Keep them everything separate, and you want to factor at this point. Factor. Can I factor my 3x squared minus 48? Answer, yes. So I'm going to leave everything else alone because nothing else is going to factor. I'm leaving everything else alone. And I'm going to factor that 3x squared minus 48. So the first way it factors is I pull out a GCF of 3. And that gives me x3 parentheses x squared minus 16. Can I factor that x squared minus 16 any further?
Yeah,
How?
you can, it's the difference of two squares because 16 is 4. So
Good.
then you would
Difference of two squares. That's what you wanted to recognize. That's exactly it. So then that becomes what? X minus 4
and x plus 4.
plus 4. Right. Oops. All my markings are coming together. And so at this point, you could just write this as one big fraction. One big fraction. Just bring it all together now in one fraction. You don't actually have to multiply at all. It's just bringing it all together into one fraction. Okay, so then how am I going to simplify? Can anything happen with the 3? Can it cancel with anything?
No.
No.
You have the x minus 4,
I have
and
an
then
x
you
minus
have
4.
your x with your 5 and your x with your 7 that you can do something with.
So I can cancel the x minus 4s. Good. So 3 is going to be left up there. Oops, let me kind of give myself a little room. So 3 is going to be left up there. X plus 4 is going to be left up there. What about the x to the 5th and x to the 7th?
Subtraction, I do believe, right?
Okay, so they're on opposite sides. Right, so we're just going to talk it out. Opposite sides of the fraction bar. So we what? We apply the quotient rule to subtract the exponents. And it becomes 5 minus 7. But 5 minus 7 becomes what?
Negative 2.
Negative 2. So how are we going to resolve that negative 2 exponent?
You move it to the bottom.
Move it to the bottom. So what's in the bottom then?
A positive x to the second power.
Right. So 3 times x plus 4 in the top over x to the second in the bottom. That's the answer. This is a good question because it's got different factoring techniques. It's got the rules of exponents, negative and quotient rule, all that jazz, and applies your rules for multiplying and dividing fractions. This is a good problem. Something I would probably want to ask. A challenging one. I'd probably make it like, 4 points instead of 2 points or something like that. But, it's a good one because it captures everything. That's what makes it a good problem. So just keep in mind your process. When you think of fractions, all those rules come into play. So here, we applied a rule for division. We flipped the second fraction. We factored the top, factored the bottom, brought it all together in one fraction, and simplified. Canceled what we could. And canceling means probably applying the quotient rule too where you can. Questions on that? So let me do this. Questions? So hopefully you're seeing a lot of what we did with the rules of exponents and factoring, all of that's getting applied now in different contexts. So that's why I left the test at what it was, because now it's just all application of all that. And these are good sort of reviews of factoring techniques. Okay, so I'm going to take this down now. And that's pretty much it for the rest of it too. There's really, I mean, now it just gets bigger, more factoring. And that's why I hope you try out 4.R.
Lord.
Try out 4.R.6 because it's a good review of the different factoring techniques. It's a good review. You're going to see it. So this is just more factoring. But this is all trinomial factoring. And GCF. Well, look, hold on. Look, you can pull a GCF out of there. You can pull a GCF out of this one too. So make it easy on yourself. If you can pull a GCF out, pull it out. Makes it a whole lot easier. Okay. More factoring. This is a good one. More factoring. More factoring. Difference of two squares. AC method. Pulling out a GCF. Pulling out a GCF as well. So this is very good problems. So if you want a review on factoring, 4.R.6 is the one you want to do. I mean, it'll help you. So it's just really more of the same at this point. Just a lot of factoring. Yeah, so we're going to do. Okay, so then that frees us up a little bit. Where are we at? We're almost done with this unit. Funny enough, we're about ready for another test after this. Where are we at? Oh yes, this is what we wanted to do. Yeah, so let's do this one right quick. Simplifying complex fractions. And if we have time, this one right here, I'll be curious what that is. Because we've already done it. I mean, in essence. I don't know. We'll see. Okay, that's not too terrible either. It's just a matter of doing it. So let's take a look at 4.R.7. It's complex fractions. Complex fractions. And before we get started, I'll open it up, but there's obviously a little bit of a review, because what does it mean to be a complex fraction? That's really sort of the gist of the whole thing. Okay, let me go to a smaller one, see if they have that. Yeah, they do. Okay, actually, let me go. Let's do this one. So when you see something like this is what we call a complex fraction. What is a complex fraction? It is a fraction over another fraction. If you see that, there's really two fractions. It's one giant fraction where the numerator is a fraction and the denominator is also a fraction. Do y'all see that? If I draw a dividing line right here, Do you see that the top is a fraction and at the bottom is a separate fraction? Okay. So with that in mind, let's hone in on this fraction in the middle. What does fraction mean? What's the operation associated with fractions?
Division.
Division. So instead of thinking of this as a fraction, why don't we think of this as a division problem? The numerator of x plus 2 over, what in the world did I do there? Oh, I moved it. The numerator of x plus 2 over 2x divided by the denominator of 2x minus 3 over 2x squared. Well, hey, we just did that, didn't we? How do we do this? We in that from the last section we just did. How do we do this?
We would need to flip the second fraction.
Flip the second fraction. Very good. So the first fraction remains the same. X plus 2 over 2x. Flip the second one, so we get 2x squared over 2x minus 3. Then what? What happens in the middle here?
Multiply.
Multiply. Okay, so now that we got that, what do we do next? You just write it as all one big fraction. Essentially, everything becomes its own. You basically just put it together. So I'll actually put it together. I was trying to be lazy, sorry. I'm gonna come over here. So 2x squared, x plus 2, just put it together as one big fraction. 2x. 2x minus 3. Okay. So can we simplify anything?
Yes, the 2x and 2x squared, correct?
Okay. And what do you want to do with that?
Make it a 1x.
Make it a 1x, right. 2's are going to cancel. X squared over x cancels to leave a plain x, right? And then what? And the numerator, everything else just, nothing else can cancel. So this is the answer. Wish it could do more, but just can't. But the moral of the story, the gist of the whole thing is when you have a complex fraction, what you really have is a fraction over a fraction, meaning a fraction divided by another fraction, so that we can apply our rules for dividing fractions that we just did in the prior section. So when you have something like this, you just flip, you write it as division and flip. Essentially what it means is that the denominator here, that's the one you're flipping. The 2x minus, the denominator is the one that you're flipping when you bring it up. Do y'all see that? So that's the basic one. There are some harder problems that we have to look at as well. It's not challenging. I mean, it's not undoable. The process is it's just going to get a little longer. But you know it. All we're going to do is take rules that you already know how to do and bring them forward into this stuff. But let me pause here. Do you all see what we're doing on this one? When we have complex fractions, our process is really take the bottom fraction and flip it. And you just multiply the two together. We took this bottom fraction and we flipped it. The bottom fraction. And then we flipped it and multiplied. Multiplied. That's it. So with that in mind, let me run through these because I'm going to go back to those other problems that I skipped over. This is the only thing I don't like about Hawks. They do not start you off with the little ones and build and ramp up. They start you off with the hard ones and ramp down. I don't think that's a good way to go. Actually, this is a good one. This is a very good one. This is a good sort of ramp up. 4 plus 5 over x, all of that over 5 minus 1 over x squared. Now this one's weird because we have fractions in fractions in fractions. It's kind of like a triple fraction, if you will. So what we want to do is we want to get it in that format that we had in the prior problem. Fraction in the numerator, let me say it this way, 1 fraction in the numerator over 1 fraction in the denominator. That's the goal, like we had in that last problem. What's going on here? Do we have 1 fraction in the numerator? No, we got 2 different things. Can we make 4 plus 5 over x, can we make it 1 fraction? Yeah, I could do that. You know how to do that. So before we do that, we're going to do a review. Okay, quick review. If I have a fraction, say 1/2, and I want to add to it another fraction, say 3/7. I don't know, just picking something. What do I need in order to do this addition of 1/2 plus 3/7 of 2 fractions?
You need the same denominator.
Boom. How am I going to get the same denominator?
You're going to figure out the least common multiple.
Sure, and it's 14. I'll tell you that right now. So how am I going to get a 14? How am I going to make that first fraction become a 14?
Multiply 1 times 7, and then 2 times 7.
So here's, if I articulated this way back then, but you probably don't remember. Take the denominator of the second fraction and multiply it to the top and bottom of the first fraction. On purpose, okay? That's what you want to do. Take that second denominator and multiply it to the top and bottom of the first fraction. And similarly, take the denominator of the first fraction and multiply it to the top and bottom of the second fraction. Doing that, you are guaranteed to always get common denominators. My point being, you don't need the least common denominator. You just need a common denominator. And this is always how, this is guaranteed to give you a common denominator. That's all you need. A lot of times it'll give you the least one as well, but you don't need that. So when we complete the tail, what do we get? We get 7 over 14 over what? 6 over 14. Oh, that's a plus. Okay.
So
And why did we
13.
have to go through this process in the first place? Why did we have to do this? Because we have addition. When you're adding or subtracting fractions, you need to get common denominators. So that's the giveaway here. That's how you know what you got to do. So when I look at this problem here, and remember your goal, I just told you, so you probably don't remember it, but when you're dealing with fractions in fractions, your goal is to get 1 fraction in the top, 1 fraction in the bottom. So I want to take the top of 4 plus 5 over x, and I want to write it as 1 fraction. How can I do that?
Put the 4 over 1.
Boom. Yes. Put the 4 over 1. Now I have 2 fractions. How do I get common denominators then? Take the denominator of the second fraction and multiply it to the top and bottom of the second fraction, of the first fraction, I mean. And then take the denominator of the first one and multiply it to the top and bottom of the second fraction. Always, no matter what context you're in, when you're in week 1 or week whatever one we're in now. Do y'all see how I did that?
Mm-hmm.
And so when we do our next step, that becomes, so 4x over 1x plus 5 over 1x. Now we could drop the 1. And that gives me what? Now I have common denominators, so I add the tops, 4x plus 5, all of that over 1x. I can't combine the 4x and the 5. They're not like terms, so I got to leave them separate. But that's how I created one fraction. It's not pretty. It's not my favorite fraction, but it's one fraction. That's what I wanted. Do y'all see that? So what you're going to have to do is you're going to have to add the fractions in the numerator. And the way that you do that, you just need common denominators. The fact that it's an x in the denominator here doesn't change the process. Doesn't change the process. You just take that, use your process for getting common denominators. So let me turn it over to you. I want 5. Now I want one fraction in the denominator as well. So that means I got to combine these. 5 minus 1 over x squared. When you see plain 5 and you got fractions, you need to think of it as 5 over 1. So what's the common denominator here? Or how am I going to get it? Let me say it that way.
It'll be 1 when you flop the x squared over 1. So it'll be 5 minus x squared.
Whoa. Hold on.
5 over 1.
Yeah. You don't flip the fraction. That's only in division. We're not there yet. We're taking, you're almost there. But what we're doing is we're taking the denominator, we're taking the top and the bottom, and we're creating one fraction. So we're taking 5 minus 1 over x squared, and we're going to join it together into one fraction. To be able to do that, we need common denominators. So take the second denominator of x squared, and you multiply that to the top and bottom of that first fraction. And so we get 5x squared over x squared minus 1 over x squared. Now we have common denominators. We can join this into one fraction. 5x squared minus 1, all of that over x squared. So all we did is we took two separate fractions and joined them into one larger fraction. Unfortunately, this is still step 1. So when you're dealing with complex fractions, you have to have one fraction in the numerator, one fraction in the denominator, which we finally achieved. So to do that, you need common denominators. Questions so far? We're not done yet, but this is the first big step. So from here, let me take this down. So what did we do? We took the top of 4 plus 5 over x, and we made that one giant fraction by saying 4x, and what we got was 4x plus 5 over x. All of that over, and the denominator became 5x squared minus 1, all of that over x squared. Now what do? We have one fraction in the numerator, one fraction in the denominator. What do?
We need to
Write it as
do
division.
4x plus 5 over x, and then flip the bottom fraction to x squared over 5x.
That is exactly right. So take the top one, write it as is, 4x plus 5 over x. Take the bottom one, flip it. We're really dividing by the denominator, but we know that now means flip the denominator into x squared over 5x squared minus 1. We're almost there. Now we have the multiplication of fractions. You just write it as one big, just join them together into one big thing. And see if you can do any canceling or simplification. And what
It
would you
turns up
say?
as a trinomial.
Say it again?
It turns up as a trinomial.
It could. I don't see a trinomial, personally.
If you wouldn't put the parentheses around it, you would have a trinomial for both of those.
Not really.
The first one you would.
Not really. A trinomial, well, if you take the x squared here and you multiply it inside, you would still have only two terms. It would still be a binomial, is what I'm saying.
Okay.
A trinomial is formed by taking a binomial and foiling it with another binomial. Most of the time, not all the time. Even then, there's some special rules. Okay, so here we can simplify. We can simplify some of the x's. So what does this become? X squared over x simplifies down to x, and then we just bring everything else down. I mean, nothing else can cancel. All that work for just canceling some x's. It's kind of a bunk problem, but anyways, that's the idea here. In this sort of problem up here, notice the top was two different fractions, so we used our concept of common denominators to combine them into one fraction. And similarly with the denominator, they were two separate fractions. We used our concept of common denominators to get them into one fraction. And then you all took it from there. One fraction divided by another fraction, you flip the second one and use your process for multiplying and factoring and whatnot. That's a big problem. They're called complex fractions, not because they're difficult, but because they're sort of confusing. But hopefully you're seeing the process is actually stuff you already know. It's just taking a lot of old things and putting them together, repackaging them. So let me pause here. Any questions on this? I don't know. I sound like a broken record on that. That it's a mashup. It's all old stuff, but it genuinely is. It's just you're asked now. Back then, you could do it only one or two rules. Now you're being bombarded with, oh wait, I got to do this and I got to do this. So it really is. It is a challenge. I'm not saying I don't mean to diminish it. I'm just saying you do know this. It's just a matter of going one step at a time to navigate to the end. Okay, briefly, we got about 5 minutes left. Let me see. Oh, that's interesting. Let's game plan this one. We're not going to do the whole thing, but I'll get you. We'll do the setup for it at least. So notice the 2 over x plus 3 over x plus 1. It's in a parentheses, and then we got divided by 5x plus 2 over x. Game plan it. What do you think we would do based upon what we've done with the other two problems?
Flip-flop the second side.
I agree. I like that. So
Well, first we have to solve the first side, correct?
Well, I like when you said, well, let's flip the second one. I agree. It's division, so let's flip the second one. So how about this part then? The 2 over x plus 3 over x plus 1.
Wouldn't it be 5 over x squared plus 1 or no?
Where? Well, you're talking about this?
Yes.
So what do we need?
Oh, the common denominators.
So we need those. We need to get those the same. But remember, and this is where it truly, if you can remember the steps, take the denominator of the second fraction and multiply to the top and bottom of the first fraction. So take the first fraction, multiply the top and bottom by that second denominator, okay? Keep everything separate. And this part of it, of the material, you're keeping it all separate. Then take the denominator of the first fraction and multiply it to the top and bottom of the second fraction. And you are guaranteed to get the same denominator. So then what do we go? Now you add them together. So this becomes 3x plus, well, let me back it up. Now, 2x times 1 plus 3x. All of that over x times x plus 1. Okay, so that's what this is up here, okay? All we did is just added the fractions by getting common denominators. Now before we go forward, can I clean this guy up? Can I clean him up at all? Any ideas on how to clean it up?
2x plus 3x plus 1.
Close. Close. Very close, actually.
Your x plus 1, you can go ahead and cut that out.
Well, that would get you, if we cut it out, if we cut that out, that would actually get us back to the 2 over x, what we started with. So we don't want to cancel yet.
Okay.
But it is tempting to want to do. I think it was Allison who said this. Essentially what she was doing, she was taking the 2 on the outside of the parentheses and distributing it inside. Okay? Where you want to clean, so why do we want to clean up is because maybe we can combine it with this like term over here.
Right.
So when we do that, that gives us 2x plus 2. That's where you were off, Allison.
Okay.
You have 2x plus 1. And so what does that give us? 2x plus 3x gives us
5x.
5x, but 5x plus 2. In the top over, now this one though we are going to leave separate. X over x plus 1. Because they're multiplying. That's what goes right here. So all this side work over here is to bring the 2 over x plus 3 over x plus 1, to bring those together into one expression. So I'm going to take this down, and I'll put it back up. So this gives us, this part was 5x plus 2 over x times x plus 1. The second part here, we turned it to multiplication and flipped that second fraction. So now what we have is the multiplication of fractions. Can we cancel? Or well, let's bring it all to one expression. That was our actual. So we said x, bring it all together. The numerator is x, and then 5x plus 2. We're not multiplying. We're not doing anything. We're just joining it all into one expression. And then the bottom is x times x plus 1 over, with the 5x plus 2. Now I can cancel. So what's one thing I can cancel?
5x plus 2.
Boom.
And the x's.
And the x's. What does that leave?
X plus 1
Where?
at the bottom.
What's at the top?
1 or x.
Which one? 1 or x?
I'm going to go with x.
But we canceled the x.
Right. Well, 1.
1. If everything cancels, there's always got to be a 1 left behind. Because remember, you can always multiply a 1 up there. That's the answer. So notice we still just applied our same rules of getting common denominators, flipping fractions, same thing. Any questions on this one?
Yes. How do you know when to distribute? You distributed for the top earlier, but not
That's
for
the
the
next.
bottom.
That's an excellent question. And so if we go back to that step, let's go back to the cleanup step that I had. What was it? 2, oof, here we go. 2x plus 1. And then over here was plus 3x. Okay. So what makes this different than, say, when we have this? Okay, why would we multiply the 2 into the x plus 1 but not do it here? Not do it here, okay? The difference is, when we take a look at something like this, that's all multiplication, x times x plus 1. Even though there's a plus sign in there, the grouping symbol means it's all grouped together, so it's really one unit. Here, we've got multiplication, but it's added to another expression. So it's two separate terms, okay? And so that's why in this particular case, because it's not all multiplication. It's not all multiplication. Here, this is all multiplication. All multiplication. X times x plus 1. That's what's going on. But here, not so much. And so that's why we want to clean it up and take that 2 and multiply it inside to bring everything together. And that's why we did that there, because of this part, this thing here was hanging on the edge, plus 3. And so we want to simplify that expression to bring it all together. Because it's not all multiplication. There's addition going on. I don't know if that helps. Let me check in with you.
I don't know. I just like whenever I do these things on my own, I feel like I never know what to do.
So
Really?
it is sort of a feeling your way around process to a degree. This one here, remember the goal. Let me say it this way. What is your goal? What are you trying to do? You want
Get the light.
Well, you want factors. You want factors. And what we mean by factoring is you got one thing multiplying another thing. Do we have factors going on up here? Do we have one thing multiplying another thing? Yes and no. What's the no? But the fact that what's the no part? This thing is not multiplying anything. It's adding it. We don't like that. We don't like that. That's the thing that required us to do some cleanup work there. Okay, I've kept you 5 minutes over. So this is essentially what the complex fractions is all about, is taking your rules of dividing fractions, joining it with your rules of adding fractions to get common denominators, and then joining it with your process for dividing fractions and factoring. Let me check in with you all right quick. Are you all using this tutor feature down here as you do your homework?
Yes.
Good. I hope so. I hope you're finding it helpful too, because that's generally the thing that when I've used Hawks in the past in other classes, that's the thing that they rely upon extensively. I mean, in those classes, though, they don't have like a live session like we have here, so that's why they use it heavily. But I'm hoping you're using it too, because these. Let me put it this way: this lecture here is sort of the primary, the first way you're getting it, but the tutor is supposed to be this like, oh, I remember when he did that. Oh, yes, I remember when he did that. So I hope you're using the tutor feature is what I'm saying. And if not, that's why I'm reminding, because someone made a note to me and it made me think, oh, I don't think you're using the tutor feature. That's all. That's why I remember. That's why I'm saying that. Okay, so where are we at? Kind of let's check back in. Okay, so we just did the stuff that was due last week. So we're right here. Okay. Um, this won't take long at all to do because essentially we've done it already. We've done equations. It's straightforward. There's just one or two problems, one or two scenarios we need to talk about, but otherwise we've done it. So this, it's amazing. I'm gonna make this the end. We're gonna have another test pretty soon. We're gonna have a test on Wednesday to capture all the old stuff, but we need to have a test on this because this is like a demarcation of new material. Because once we finish 1.9, this stuff that follows has no bearing on anything else. I mean, we'll do some radicals or whatnot, but it's not going to be like what we've been doing with factoring and radicals and complex numbers and all that stuff. This is 1.9 ends that particular unit. So we're probably going to be looking to have another test real soon because I don't want to invade. I want to keep it discrete. I want to keep it separate. And I don't want to invade this material with the stuff that's coming up. It can make it a little challenge. I mean, you're going to do it on the final, but I don't want to do that to you in advance. So, where are we at? I would probably, let me think about it. I'm thinking probably November 6th, next Wednesday. Just kind of it's a back-to-back test, but I'm taking one big unit and chopping it up into two smaller test units. That's my rationale behind it. I think I'm going to be looked at doing there. Let me see. 6th or 7th, probably 7th. Or 6th. I don't know. We'll think about it. I'll think about it. Anywho, so Wednesday, we're going to have the test here on, what is it? All the way from, where are we at? No. Oh, 6.R.1 all the way down to what? Where did I say?
1.9. No, that's the new lesson. That's the new.
Yeah, I divided up into two small ones. Thank you. I knew it was 1.5. So 2 point. I need to write this down, huh?
6.R.1 through 1.5.
Yeah, through 1.5. 6.R.1 through 1.5 is one test. I basically took one giant unit and broke it up into two. And then the next one, pretty shortly after that's going to be the rest, 2.R.2 all the way to 1.9.
Okay.
And hopefully you can see why I did that is because the problems here from 2.R.2 forward are a bit longer to do. They're going to take a little more time to do. So that's why I wanted to break it up because I think you're going to find the first part to be not so bad, pretty quick. Anywho. Okay, so I've kept you long enough. I'm sorry. I'll get this video processing. The video from last Thursday for some reason didn't process and save. I'm going to try to explore to see if I can fix it, but it may not be recoverable. So I'm going to get this one cooking here for you. And if you have any questions on it, let me know. You would want to be done through this material. It says October 23rd. Obviously, we're not going to make that because I don't think I accounted for the fall break appropriately. So it's not. So don't worry about the due date. But you want to probably have this material done by Sunday. What is that? The 2nd, 3rd.
I do have one question before you go. So tomorrow, is it going to be new material or is it going to be review for Wednesday's test?
Both. We'll do. I'll do some factoring review, but that's why I wanted to do this stuff tonight. If you do this, if you work on 4.R.5 and 4.R.6, that's going to give you a lot of the factoring that you need. So if you haven't done that already, I encourage you to start working on that because that's going to help you with the factoring.
Okay. And so the reason I'm asking, I know you've been recording them. Is there any way that you'd be able to upload tomorrow night? I have a function for one of my kids. It's a soccer banquet.
Oh yeah, definitely.
And that way I can watch it before the test. So make sure I didn't miss anything on the review.
Sure. Yeah, definitely.
Okay. All right. Thank you very much.
All righty. Well, I hope. What's the function for?
It's a soccer banquet to find out if you're on varsity or JV and all that fun stuff.
Okay. Well, good luck. I hope.
All right.
Hope it's a good one.
Thank you.
All righty. Okay. Well, I'll get this video processed and uploaded for you. I'm going to do it tonight. And keep plugging away at the homework. You know, even though there's the due dates here, obviously they're not matching up. I didn't line up the fall break, so that's why it's a little off here. But you would want to just shoot for this stuff here, all of this, you know, this Sunday. Sunday, what is it, November what? What is that, November?
2nd, I believe.
Yeah, thank you.
The 3rd.
Yeah, 3rd. I don't know. I'm terrible at the calendar. No,
I
November
have
3rd.
Question.
And then, so we'll probably then have the test on Wednesday of that following, up next week, so that we can kind of keep it close in time. I don't like to have the test and the material too far apart because it just, particularly because once we start the new stuff, you're not going to see the old stuff again until we get to the very end. So I really want to have the test close to it so that it's not so far apart. Okay, yeah, go for it, Jackie.
Real quick. So you know how mine doesn't link over? Do you want me to just wait and send you all my stuff later?
That'd be good. However you want to do it.
I know that my grade on your side says, hey, you have like a 17, but like I don't have a 17.
Oh, I don't like that. No, send me your screenshots. I'll get them right.
It doesn't matter to me because I know that once I send them to you, you just have to plug them in. So like the one on Hawks is like, hey, you're doing good, but the one on your side's like, hey, you need to fix that.
Not so good. Yeah, I hear you.
I'll send them to you in a little while, but I'm just working on them. That's all.
That sounds good.
All right.
I have a question as well. I have work Wednesday night, and like I just want to see like how many questions possibly is going to be on it.
I'm thinking 10 to 15, probably a little more, probably about in that range, probably closer to 15 because the questions are not arduous.
Is it like last time where you could take it throughout any part of the day on Wednesday and we don't have class on Wednesday?
Right.
Oh, okay.
Yeah,
that's great.
Same thing. Yeah, exactly.
Okay, well, that's good because like it takes me like literally like 30 minutes plus to figure out a problem.
Oh, yeah. I don't know if it's going to take you that long. You have just kind of listening to you tonight, you got a good sense of what's going on with all the problems. So I don't think it's going to be that bad for you. The next test, this other material, I don't expect it to be as many problems. I probably would venture more on the 7 to 10 because the questions are longer and there's less sections that I have to deal with. So anyways, just to kind of give you a heads up. So in the grand scheme, probably the two tests combined would be 25 questions, things like that.
Okay, well, that's what I wanted to know. Thank you very much.
Okay. All right, well, I'll get this video processed for you here. Hope you have a good night. Thank you for joining me, and thank you for hanging with me late. We'll connect tomorrow. Hope you have a good one.
Yes, sir. Y'all as well. Bye-bye.
Okay, bye-bye.
Come on, son. Let's go to the store.